In this set of notes, we're going to learn how to solve a system of equations using a more algebraic method called elimination. In order to do this, we're going to find the solution by eliminating a variable using mostly addition, maybe sometimes subtraction. So, what's the method by which we can already solve a system? Well, we've been seeing how to solve a system using the graphing method, where we've been graphing the equations on Desmos and then looking for the point of intersection, as this is the point that lies on both lines and would make both equations true if using algebra. Let's think about how we would add 623 plus 725. I want you to pause the video and I want you to do your work in this box to add these two numbers, not using a calculator. Press play when you're ready to check your answer. Did you get 1,348, and did you set up your work this way? It's okay if you didn't, but hopefully this at least looks familiar to you. What I want to point out is that notice that we put our plus sign here, and we also have a line to kind of show that we're adding. We're going to use similar symbols in what we're about to do, and so think of these as we go through these problems. So now we're going to solve an equation by eliminating a variable. Let's not forget that we can check our answer using Desmos or by replacing x and y with what we think our solution is to make sure it balances both equations. So first, let's actually plug this into Desmos and see what our answer would be. So I can see when I type these two equations into Desmos, I've got my two lines, and here's my point of intersection. And so that means my solution is going to be the point 1, 3. Let's see if I can find this using algebra. So my goal is to get a variable to eliminate, meaning I want to make it 0. What I can see in example 1 is that I have a 2x and a negative 2x. And so if I were to add these two terms together, they would make 0. So what I'm going to do is I'm going to draw my line below my two equations, similar to how I drew a line here when I added 623 and 725. The next thing that I'm going to do is I'm going to put a plus sign. Now I like to put a little circle just to remind myself that it's kind of like off to the side, and I'm going to put a plus sign in there. So again, this plus is similar to how I had a plus here. Now I can combine like terms. So I've got 2x plus negative 2x, which would be 0. 3y plus 5y would be 8y. I bring down my equal sign just like I always do when I'm solving an equation. 11 plus 13 is 24. Now I have an equation that has one variable in it. I don't have an x and a y anymore, I just have a y. And so to get y by itself, what I could do is divide both sides by 8, which would make y equal 3, which is exactly what I had found in Desmos. Now I still need to find the remaining half of my ordered pair, and so I can go back to either one of my equations. I'm just going to go to the top one, and I'm going to rewrite it, but I now know that y is actually 3. So I'm going to write 2 times x plus 3 times 3 equals 11. I would then do 3 times 3 to get 9. And now I can solve my equation the way I normally would by subtracting 9 from both sides to get 2x equals 2, and then divide both sides by 2 to get x equals 1. And so now I have both half of my ordered pair, and the last thing that I want to make sure I do is to actually write it in ordered pair format to show that it's a point of intersection. Let's take a quick look at example 2. So looking at example 2, can you see which of your two variables, x or y, you would be able to eliminate using addition? Since you've got 3x and negative 3x, this is the variable that we're going to be able to eliminate. So again, we're going to start by drawing our line, showing that we want to add, and now we're ready to add our like terms together. 3x plus negative 3x would be 0, 4y plus 5y would be 9y. Bring down my equal sign, 8 plus 10 would be 18. Then to get y by itself, I would divide both sides by 9, which means y would equal 2. But I still need to find my x value, so in order to find my x value, I could either change y to 2 in my top equation or y to 2 in my bottom equation. I'm going to choose the top since I don't see any negatives. So to do this, I would do 3 times x plus 4 times y, but I now know that y is 2, equals 8. My next step would be to simplify my equation by multiplying 4 and 2 to get 8. Then I would get x by itself using reverse PEMDAS, so subtracting 8 from both sides, which would get me 3x equals 0. And then my last step to getting x by itself would be to divide both sides by 3, which means my x coordinate would be 0. For a final solution, or point of intersection, of 0, 2. I could check this by going to Desmos and graphing my two equations, and I should see that they intersect at the point 0, 2. Or I could replace x and y in both equations, x with 0, y with 2, and see if it works. So 3 times 0 is 0, 4 times 2 is 8, 0 plus 8 is 8, so it's a solution to the first equation. Negative 3 times 0 is 0, 5 times 2 is 10, 0 plus 10 is 10, so it's also a solution to the second equation. On example 3, the variable that I'm going to be able to get to eliminate is y, since this is technically a 3y, and this is technically a negative 3y. So I'm just going to get you started here, and then you're going to complete the problem on your own. So we're going to draw our line, we're going to put our circle, we're going to show that we're adding, and so I've got 4x plus negative 5x, which would be negative 1x, 3y plus negative 3y, which would be 0, bring down my equal sign, 2 plus 2, which would be 4. So at this point, pause the video, finish finding your x value, don't forget to find your y value, put your answer in as an ordered pair, press play when you're ready to check your answers. So my final answer, or my point of intersection, is going to be negative 4, 6. To finish getting x isolated, I divided both sides by negative 4 to get an x coordinate of negative 4. I then replaced negative 4 in my top equation. 4 times negative 4 was negative 16, plus 3y equals 2. I then added 16 to both sides. 3y equaled 18, and then divided both sides by 3 to get my y coordinate of 6. Again, I could check my answer by going to Desmos and seeing where these two lines intersect, or I could replace x in both equations with negative 4 and y with positive 6 and make sure they produced two balanced equations. So on example 4, which variable do you think you would be able to eliminate? Do you think you'd be able to eliminate x's or y's? Since the y coefficients are both 6, that's going to be the variable that we can eliminate. Now sometimes people might say that instead of adding here, we could subtract, because 6 minus 6 would be 0, which is a totally fine approach to this problem. You can subtract everything just in the same way we added. You would end up with 5 minus 7, which would be negative 2x, 6y minus 6y, which would be 0, and 4 minus 8, which would be negative 4. However, some people would prefer to always add rather than subtract. So one thing that we're allowed to do is we can change an equation as long as whatever we do to one side we do to the other. It's kind of in the same way that when you change a fraction, say from 1/2 to 2/4, the real reason we're allowed to do that is because we're multiplying top and bottom by the same number. We can do that with equations as long as we do it to every single piece of the equation. So what I could do maybe on my top equation is I could multiply it by negative 1. I'm going to actually show this with brackets to show that I'm doing it across an equal sign. And so I've got negative 1 times 5x, which would be negative 5x, plus negative 1 times 6y, which would be negative 6y. And then I can't forget to do negative 1 times 4, which would be negative 4. So I've kind of distributed this negative 1 across the entire equation. Now my bottom equation, I'm going to keep exactly as I see it. So I'm just going to draw a little arrow here, a little arrow here. So I've got 7x plus 6y equals 8. And so now that I have a positive 6 and a negative 6, I could go back to using addition to eliminate my variables. So I'm going to draw my line, draw my circle, put my plus, and let's add our terms. Negative 5x plus 7x would be positive 2x. That's because a negative 5 plus 7 would be a positive 2. Negative 6y plus 6y would be 0, so it's gone. Bring down my equal sign. Negative 4 plus 8 would be positive 4. And then to get x by itself, I would divide both sides by 2, which means my x coordinate would be 2. Now to find the missing y coordinate, I would probably go back to maybe this equation that's all positive and change y to what I now know it to be, or sorry, change x to what I now know it to be, which is 2. So that means I would do 5 times 2 plus 6y equals 4. 5 times 2 is 10, plus 6y equals 4. I would then subtract 10 from both sides of my equation. to get 6y equals negative 6, and then divide both sides by 6 to get y equals negative 1. And this means that my point of intersection would be 2, negative 1. So let's look at example 5 and get started on this one. So which variable do you think you're going to be able to eliminate? X's or y's? Since y seems to have, in this case, a negative 4 in front of both of them, but our absolute values of our numbers are the same, we're going to focus on eliminating the y value. So in this equation, and it's not really going to matter which one you pick, I'm just going to choose to keep my top equation the way that it is. So 8x minus 4y equals negative 4. And so for my bottom equation, to make it a positive 4 so that way I can add, again, I'm going to use brackets because I want to show that I'm going across the equal sign. So I'm going to multiply everything by negative 1. So negative 1 times 3x would be negative 3x. I'm just drawing arrows to show that I'm just changing or keeping the equation the same. Negative 1 times negative 4y would be positive 4y. And then negative 1 times negative 14 would be positive 14. Now that I have a negative 4 and a positive 4, that means I'm ready to add. You also could have done this at the start by subtracting. So I'm going to show that I want to add, and so now I'm going to add my like terms. 8x plus negative 3x would be positive 5x. Negative 4y plus 4y would be 0. And then lastly, negative 4 plus 14 would be 10. So at this point, I'm going to have you complete this equation, find your x coordinate and your missing y coordinate. Be sure to write your answer as an ordered pair. And then you can also go ahead and complete example 6. Pause the video, press play when you're ready to check your answers. So on example 5, to get x by itself, I divided both sides by 5 to get an x coordinate of 2. I then put that in this top equation here and did 8 times 2, which is 16, minus 4y equals negative 4. Now remember, we're trying to get a positive 16 to become a 0, so that means we would do 16 minus 16 because that's 0. This negative sign in front of the 4y just comes down along with it. Negative 4 minus 16 would be negative 20 because keep, change opposite, and then divide both sides by negative 4. A negative divided by a negative is a positive, so we get a positive 5. So the point of intersection of these two lines is 2, 5. I encourage you to check your answers using Desmos. Now in example 6, I know that I can eliminate my y variable because I have the negative 3's in front of each. I'd like to make one of them positive so that way I could add. Now I could have multiplied the top equation, but these two items were already positive. It would make them negative. What I see here is that if I multiply by negative 1, everything will go from negative to positive, which is just kind of nice, but it doesn't really matter what you pick. So my top equation stayed the same, 9x minus 3y equals 18, and by multiplying everything by negative 1 in the bottom, it just changed the sign of every item. I'm then ready to add because negative 3y plus 3y would be 0. 9x plus 7x was 16x, and 18 plus 30 was 48. My equal sign came straight down. Dividing both sides by 16, I got an x coordinate of 3, and I plugged that back into my top equation. 9 times 3 was 27, minus 3y equals 18. Again, to get rid of a positive 27, I had to subtract. 27 minus 27 is 0. The negative 3, or the negative in front of the 3y just comes down. 18 minus 27 was negative 9. Then I divide both sides by negative 3 to get a y coordinate of 3. Let's look at word problem 1. So it says, Dan goes to a store to buy a charger and a computer game and pays $70. John goes to the same store and buys the computer game and returns the charger and pays $50. So let's let x represent the cost of the computer game and y represent the cost of the charger. And we're going to write a system of equations to solve this problem. So Dan is buying both items. So Dan's cost, which is $70, is going to be the result of adding the cost of the computer game, which we called x, and the cost of the charger, which we called y. Because if he brings both of these items up to the cashier would add both of these items together, and this is the price that Dan had to pay. Now when John goes to the cashier, he brings the computer game, which is going to cost him X dollars, but at the same time, he's returning the cost of the charger. And so when you return an item in the same transaction, what it would do is it would be subtracted from the cost of the item that you're buying. So whatever his computer game costs, he's going to pay Y less dollars, because Y is the cost of the charger, than that. And we know that his total is 50. And so now if I draw my line and my circle, I could eliminate y because I have a positive 1y and a negative 1y by adding these two together. So if I add, I know that my y is going to eliminate. X plus x is 2x, and 70 plus 50 is 120. I would then divide both sides by 2, which means that x would equal 60. And since my key tells me that x is the cost of a computer game, that means my computer game cost me $60. So now I could go back to Dan's equation, which was x plus y equals 70, and do 60 plus y equals 70. And it's probably pretty clear that this number would need to be 10, but just in case it's not, I could subtract 60 from both sides to get y equals 10. And so that would mean that the cost of the charger is $10, and my ordered pair would be 60, 10. Now I can prove this by saying, okay, a charger, a computer game plus a charger, 60 plus 10 is 70. The computer game, that was $60, but the return of the charger for $10 would be 60 minus 10, which would be 50. Let's look at word problem 2. So it says, Rima is older than Ken, and the sum of their ages is 50, and the difference of their ages is 12. We're going to use a system of equations to find their ages, and we're going to identify two variables. So the first thing I don't know is how old Rima is. So I'm going to let x represent Rima's age. I also don't know how Ken is, so I'm going to let y represent Ken's age. And so it tells me that the sum of their ages, and sum means to add, is 50. So if I add x plus y, I'm going to get 50. It also tells me that the difference of their ages is 12. Now difference means to subtract. Here's an important fact. I'm getting a positive 12 as my answer. And so that means that when I subtract, I have to make sure I do the bigger number minus the smaller number in order to get a positive answer. And since they told me that Rima is older than Ken, that means the bigger number would be x. So I'm going to do x minus y equals 12. I can see that my y's are opposites, positive 1 and negative 1, and so that means I'm ready to add these equations in order to eliminate a variable. So go ahead and draw your line, get ready to add, and you're going to finish solving this one on your own. Press play when you found both ages and you're ready to check your answer. So in this case, when I add, I get x plus x, which is 2x. Remember, y plus negative y cancels. 50 plus 12 is 62. So my equation is 2x equals 62. And then divided by 2 to get x equals 31, which is Rima's age. Now remember that if I took Rima's age plus Ken's age, I would get 50, which means that Ken's age would need to be 19. I can also check that this makes sense by checking the difference of their ages, which the difference between 31 and 19 would be 12. Let's take a look at the puzzler. So it says that the sum of the digits of a two-digit number is 12, and the difference of the digits is 2. We're going to solve this by writing and solving a system of equations, and we're going to assume the tens digit is larger than the units digit. So if you think, for example, about, let's just say the number 35. 3 is my tens digit, and 5 is my ones digit, or my units digit. Now in this case, I don't know the number, so let's let x represent the tens digit and y represent the units digit, or the ones digit. And so it tells me that the sum of the two-digit number is 12, so that means if I add them I would get 12, and the difference of the digits is 2. And again, since the difference is a positive 2, difference means to subtract, I need to make sure that in order to do a subtraction problem and get a positive answer, that I do the bigger digit minus the smaller digit, and it told us that the tens digit is larger, and so x is my tens digit. So again, I'm going to do x minus y. So my system, x plus y equals 12 and x minus y equals 2. I'm ready to eliminate my y variable since I've got a positive y and a negative y using addition. Go ahead and solve this system using elimination. Make sure you get both digits and then say what the number is. Pause the video, press play when you're ready to check your answers. So by adding my two equations together, x plus x was 2x, y plus negative y was gone. 12 plus 2 is 14. Divided both sides by 2, my x digit was 7. If 7 plus y had to equal 12, that would mean that my y digit would be 5. So as an ordered pair, the intersection of these two lines would be 7, 5. But in the context of this problem, remember I was looking for a two-digit number where the first digit was x, which was 7, and the second digit was y, which was 5. And so that means that my two-digit number is 75. Thanks for listening to part 1 of the notes. Part 2 will be coming soon in another video.